Hi students, it's Mrs. Gravenese with your next math lesson. Today we're going to look at multiplication patterns, and this comes from your My Math book, Chapter 2, Lesson 4. So let's take a look at some examples. We can do mental math even with pretty large numbers in multiplication. For example, if we have something such as 5 times 7, well, that's a basic math fact. We can find that on our times tables. 5 times 7 is 35. Well, if you can figure that out mentally, then you can actually multiply a whole bunch of numbers mentally, even if they're quite large. For example, if I make the 5 a 50 and multiply it by 7, 50 is quite large. However, knowing that 5 times 7 equals 35 will be helpful, because 50 times 7 is really 5 times 7, 35, with an extra 0. Because 50 was in the tens place, we need to consider that when we have our product. All right, let's try another one. What if I take 50 and make it 500 times 7? Well, I can work with that same basic fact. I can still take my 5 times 7 fact, which is 35, and this time I annex these two zeros here into my product, making the answer 3,500. And I can continue on and on and on and on. Well, what happens if I add zeros to both factors? So let's keep our basic fact, 5 times 7. And now I'm going to add zeros to both factors, making it 50 times 70. Well, my basic fact is still there. 5 times 7 still equals 35. And now I have a total of 2 zeros that I need to put into my product. So 50 times 70 equals 3,500. And I can continue to add zeros wherever I want. So now I have 50 times 700. 5 times 7 is still 35. And then let's count up all the zeros in our factors. 1, 2, 3. So I need to place 3 zeros in my product. All right, I want to show you an example of one that often confuses students. So let's say we have the problem 4 times 5. Well, 4 times 5 is 20. And let's build a pattern on that. What if I had 40 times 5? You have to be careful here. Because our original product from our fact already has a 0, we have to remember that when I write my basic fact, 4 times 5, that already has a 0. But I still need to put in the number of zeros from my factors. So I still need to add another 0. Students will often forget to add an extra 0 if they need it. So let's expand on this pattern. If we have 40 times 50, it's not a 2 with 2 zeros. It's a 20, because 4 times 5 equals 20, with 2 zeros, making the product 2,000. All right, let's switch over to exponents and multiplication patterns. So let's say we have the number 12, and we take 12 times 10. Well, 12 times 10 is 120, because it's 12 times 1 with an extra 0. The number 10 is really 10 to the first power. We just don't usually ever write the exponent of 1 because it doesn't change anything, okay? 10 to the first power is a 10. But what happens when we change that exponent? So what happens when we say 12 times 10 to the second power? Well, let's think about what 10 to the second power really is. 10 to the second power is 10 multiplied by itself 2 times. And 10 times 10 equals 100. So 12 times 10 to the second power is really 12 times 100. And then let's figure out how many zeros. We have 12 times 1, which is 12. And then we have 2 zeros to put into our product. Now, what do you notice about the product? The number of zeros that we added in that product compared with the exponent. It's the same. So our exponent was 2, and we added 2 extra zeros to our other factor. We added 2 zeros to the 12. So let's take a look at another one. What happens if I have 12 times 10 to the 5th power? Now this only works if your base is 10. Okay, if your base is a different digit, it won't work because we're talking about powers of 10 here. 10 times 10, however many times. And that's what gives us our zeros. So 12 times 10 to the 5th. What I can do is write my factor 12 and then add 5 zeros after that. 1, 2, 3, 4, 5. And let's get our commas in the correct places. So 12 times 10 to the 5th power is 1,200,000. Well, why? Let's break down 10 to the 5th power. It's 10 multiplied by itself 5 times. And let's break that down. 10 times 10 is 100. 10 times 10 is 100. And then we have one more 10. And when we do this, we can just count up all the zeros. So we have 100 times 100. Well, that's a 1 with 4 zeros, or 10,000. Then we have this extra times 10, which means I have to add another 0. So it's a 1 with a total of 5 zeros. 1, 2, 3, 4, 5. Boop. So 10 to the 5th power is really 100,000. And if I were to do mental math like in the other problems, if I had 12 times 100,000, I would take 12 times 1 and then add in 5 zeros. And you can see we get the same product. Now, which way was easier? Breaking up 10 to the 5th power as repeated multiplication, or just saying when I multiply a number by 10 to a power, or a power of 10, then I can just use the exponent to add those zeros. I think using the exponent is much faster. All right, let's try one more example with an exponent. So let's say we have 37 times 10 to the 4th power. This is mental math. So what we do is we take 37 and we put 4 zeros after that to get a product of 370,000. So multiplication patterns is all about using mental math to multiply numbers that are quite large, but those numbers have to be multiples of 10 or powers of 10 that you're multiplying with. So this doesn't work for every single multiplication problem. Notice the pattern that we've had powers of 10 times a number, or we've had multiples of 10, such as 200 times 3,000. They're both multiples of 10 because their ones place is a 0. So let's go ahead and do this one. Why not? Find your basic fact. 2 times 3 equals 6. Now, how many zeros must we add? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that product is 600,000. All right, I hope you found this video helpful, and you can check back in with me for the next one. Have a great day.